Okay, factorising quads when there is a difference of squares. First of all, what I mean by a difference of squares is you have plus a number and minus that same number. When you expand, you'll note that there are no x's. So often you come across these and you see an x squared, and you often see a squared number. Why it's called the difference of squares is it's because it's a squared and the difference is always a minus 2 squared. And that's why it's called the difference of squares. So the questions will look much like this. Factorise x squared minus, and you think of a square number like, it's not a square number. 25 is a square number. Okay, and to factorise this, we want to put into a quadratic looking bracket, so I always draw the brackets in first. I put an x in the front, and I think I need to add a number and subtract a number, but the number has to be the same. And I suppose the quick way to get there is to take the square root of 25. So add 5, subtract 5. Okay? And that's factorised. Factorising a quadratic that's the difference of squares. I'll do another example. Some x squares, and it's always a minus that you'll see, because you have to have a plus and a minus, and you end up with a negative. 144. So most likely, if you forget this rule, you'll probably start trying to factorise it into a single set of brackets, and you'll be looking for something common, and you'll think this, you almost go, oh, this can't be factorised, but then you'll remember Mr. Arden said if it's a square number, then you take the square root of 144 and it's plus x plus 12 x minus 12, and that would be that problem fully factorised.